Hi guys, I'm Darren and today we're going to look at what's new for fixed wing in iNav 3.0. So about 6 months ago, I wrote a document for iNavFixedWingGroup.com and also released a video on here for the new release of iNav 2.6. And thank you very much for you guys. I got a lot of positive feedback about that. A lot of you said it really helped to discover the new features in iNav that are useful for you as a fixed wing pilot. So thank you for that. And while we're on the subject, please give this video a thumbs up and leave a comment as what you're most looking forward to in iNav 3.0 and if this video helped just as much. So whereabouts are we right now? Well, if we have a look on GitHub, we can see that iNav 3.0 was released about 17 hours ago. While we're here, let's just take a quick look at how to download. You just go to this releases here. I'll put this link in the video description. Go down to the bottom of this page and you can see in the assets section, you have different zip files for different operating systems. Just download the one for your operating system, extract it, and then you can run it. But anyway, if we go over to iNavFixedWingGroup.com, we can see that there's this guide here, and if 3.0 was released about 17 hours ago, this was released about 16.5 hours ago. Basically what we're going to do is go through this document, have a look at the key features that I've picked out, and just basically share in video, because I know a lot of you guys prefer videos to reading. But if you do want the document, I will also link it in the video description, but it has all the pull releases linked, so we can see we've got a table of contents going over everything. But if you see a number with a hash and then a number, if you click that, it will go to that pull request so you can see more details on it. For example, the automatic rates tuning, we click on that, it'll bring up the pull request and you can take a look at all the information on there. So let's close that down. Right, so a couple of questions that will probably pop up. I might as well get out of the way at the beginning. I'm not going to go through how to update. I've got a video for that which I'll put up in the top corner. But basically that will cover from 2.6 to iNav 3.0. If you're on an earlier version than 2.6, you'll need to check out the release notes for 2.6 to see what you need to do to your diff file to get it ready for 2.6, if that makes sense, or just follow the instructions on the iNav repository to get you updated to 3.0. But basically, if you have your diff file, remove the profiles, remove the adjustments because all the IDs have changed. Maybe take a screen grab of adjustments if you have them so you can add them manually afterwards, and then go from there. You'll need to do the presets, but again, I've covered all that in the video. What I don't cover in the video, which I will cover briefly, is if you've been running the release candidate 1 or 2 for iNav 3.0, the update process for that is a lot simpler, of course. So what you'll want to do is do a diff all, flash the stable release of iNav 3.0 with full chip arrays, then you can restore the diff. But what I would recommend that you do is when you fly it again, go through the auto tune process again, because some of the ranges for stuff like feed forward has been extended, so you may find that your plane flies better. So the process, if you're on a release candidate, is really quite simple. But anyway, what has changed? And yeah, a lot has changed. It was originally going to be called iNav 2.7, but so much has gone into it, and to be honest, a lot of that is thanks to Alexander Van Sass, who's put in quite a lot of work with the auto tuning side of things and level, and yeah, a lot of other things as well. Just look on GitHub, you'll see lots of pull requests from Alex. But anyway, a lot of that is the reason why it's actually been bumped from 2.7 to 3.0, and that also allowed the freedom to do things like change the IDs in the adjustments, which, you know, it might have not have been great if it's just like a sub release. So taking that, the iNav 2.6 configurator will not work with 3.0. Likewise, iNav 2.6 firmware won't work in the 3.0 configurator. You can of course use the CLI for doing stuff like diffs, but as for actually changing settings using the user interface, you have to be on 3.0 to use 3.0 or 2.6 to use 2.6. There's no sort of overlap this time. So what has been added? So the first thing that I've got in the document is the automatic rates tuning, which has been added to auto tune. So the reason this is the first thing is because this is one of the main reasons people had bad tunes. When you see stuff like dolphining on, we saw it on a lot of twin planes, like the Crosswind Mini. Andrew Newton's was a prime example of that. Also Josh Galt's. They're all dolphining, and a lot of that was because the rates were simply too high. Andrew had a physical issue as well, but the rates would have also been a contributing factor. But also rates can mess things up, like if you do a loiter, for example, and you find that your aircraft banks really quickly over and goes beyond the set maximum bank angle, that will be rates being incorrect. So this automatic rates tuning system is going to just completely knock that out of the water, hopefully. So what it will do is when you install iNav 3.0, which I'm going to do a video for installing from scratch very soon using the Talon 250G that I'm reviewing. But when you install it, you will apply a set of defaults. And these are based on either a tailless plane, so that's something like a flying wing, like a AR wing, a tailless plane like a Mini Drac or a Strix Goblin, or the other option is a plane with a tail. So this has an extended piece with an elevator and potentially a rudder as well, but it's mainly the sort of elevator. So that will include like a Drac Boomer kit, for example, a Sky Hunter, or a traditional plane. Crosswind Mini is a good example. Albert is very popular. So they will obviously be planes with a tail. So you choose that default, and what that will do is set a base level PIDs, which should be pretty broad spanning. So even if you've got a big or a small, it should all still be flyable. It won't fly great, but it shouldn't have any incidents, that sort of thing. The rates have been purposely chosen to try and fit as broad a range of aircraft as possible. So if you have something that's small and agile, you'll find that when you first put it up, it's really slow to react because the rates are really low for what the aircraft is. But as you do the auto tune, the rates will increase and it will start flying better and better. So just stick to that. Do your auto tune. With auto tune, make sure you do it in acro mode. Don't do it in angle or horizon or anything like that. It's got to be acro now. And make sure that you do full stick deflections. And also it's important to have rests. So what you'll do is do one axis at a time. So for example, if we're doing a roll, do full stick left for a second, then center it. So at the start, that might only be a very subtle movement because, as I said, the rates are really low. So it will do full stick left and then just leave it for a little bit. Then full stick right and leave it for a little bit. Just keep doing that and you'll find that eventually it will actually get better and better, but you want to do it about 10 times because the first few times it is still just learning about the aircraft before it actually adjusts anything. So do that with both roll and pitch. And you don't have to do full loops or rolls. You just need to do that full deflection on the stick to get the aircraft moving. A good thing to set up is an OSD for tuning. Even if you're not manually tuning anything, just having an OSD where you can see the PID or PID FF now for the roll axis, the pitch axis, and if you have a yaw axis, that as well. And then you can actually watch them change and just keep doing the auto tune until they stay pretty static. They may change a little bit, but once you're there, it should be locked in. Also, when you're doing the auto tune, it's good to do it in sort of a throttle range that you're going to be flying mostly. So if you're building a speed plane, do it at high speeds. If you're doing a cruiser, say for example, your cruise throttle is usually around 40%, maybe just bump the throttle up a little bit to 50%, maybe 60%, around that area, and do your auto tune at that throttle. And also make note of your throttle when you're doing the auto tune, because you can use that later on to set your TPA breakpoint
by setting the TPA after you've done the auto tune, you can forget about the breakpoint. You've already got it from when you did the tune. All you'd need to do then is adjust the percentage if you find you have issues. So that's basically the auto tune. But anyway, let's get back to this automatic rate tuning. The default setting, I believe, is auto, so it will do everything. What that will mean is if your rates are too low, it will increase them. If it thinks they're too high, it will decrease them. And to be honest, that is one of the more important parts, is people in the past have set their rates way too high. So we've seen stuff like 200 degrees per second on the pitch for a Ranger 2000, for example, which is ridiculous. It should be about half that. So that will bring the rates down if they're too high. But of course, we're starting with really moderate rates, so you'll find that the rates will most likely go up unless you have got a really big plane, in which case they may stay around the same. So that's the auto. It will increase or decrease depending on how the plane is flying. There's also a limit option which will only decrease. So you would set your maximum rate. So the reason you'll do this potentially is if you have an agile plane, but you don't actually really want it to be agile. So let's say, for example, we have a Nano Goblin. Brilliant example. That thing I've had at 540 degrees per second on the roll axis, and that was recorded and measured in manual. So that thing can roll really, really quick. But if you didn't want it to do that, you could maybe set the rates to, I don't know, 240 degrees per second, pulling a number out the air, and then you set the rates tuning mode to limit, and it would only bring them down if it thought that was too high. The only issue potentially then is if you have a pitch rate that's too low, it wouldn't bump it up, but yeah, you have to choose what you want to do with that airframe. And then the last setting is fixed, which basically works like the old system. So if you're setting them properly, that means flying in manual, doing rolls and counting frames to work out your actual physical degrees per second rates, taking 80 or 90% of that, and then using that as your rates. But to be honest, put it in auto, it works well. Just forget about it. Just let it do its job. But anyway, I've spoken on that for quite a while, but it is, I think, one of the most important changes in iNav 3.0. Right, so this next section is something that's confusing a lot of people, and people are thinking that it's doing something different to what it actually does, and that is the new auto level feature. Now, before I get into anything, I just want to say this has nothing to do with righting the aircraft if you let go of the sticks. If you think it works like adding angle to any other flight mode, no, that's wrong. It's got nothing to do with that whatsoever. If you want a flight mode where if you let go of the sticks, the aircraft will automatically right itself and fly level, you use angle or horizon. They're the only two flight modes that you're actually in control of everything, where if you let go of the sticks, it will right itself. The auto level mode has nothing to do with that whatsoever. This is purely about flight controller pitch board alignment. So what I'm going to do is bring up iNav Configurator, and we can have a look at a bit more what I mean. So what I'm talking about, if I rotate the wing, the board pitch alignment that I'm talking about is planes don't fly level with the actual wing level. There's usually a little bit, it's really tricky to do. There's usually a little bit, I know that's exaggerated, but there's a little bit of nose up. It's usually about -4 to -8 degrees. So something like that. That's the normal sort of flying attitude. And before, to adjust that, what we'd do is pop into configuration, and down here where you've got your degrees, there used to be pitch and roll degrees. So you could adjust the pitch to -5 degrees in that case, and it would sort of adjust the model or the board alignment so that the model would fly dead level. So going forward, completely forget about what is here and what was here for board alignment for getting the plane flying level. You'll see your degrees is still here. That's purely for if you've sat the flight controller in the plane where the arrow isn't pointing towards the front. So if you've rotated it 90 degrees, you can still put the 90 degrees in there, and it will then think that that is the front of a flight controller, for example. If you have done something weird, like flipped it upside down inside the fuselage to mount it, or even on the side, you now need to go into CLI to adjust that. So the easiest thing to do, go in CLI, we do get board. You can see there's a line board roll, a line board pitch, and a line board yaw. Now they are the 3 axis, and only use these for setting basically the front of the flight controller. So for example, if we've rotated it like that, we would want to add 900 on the board pitch. Or if we've rotated it like that, we'd add 900 on the board roll, for example. But just use these for getting the front of the flight controller correct. So when your plane is back towards you on this setup screen, everything works correctly. So left, right, up, down. That's all you use those for. So for adding the little bit of up trim we need to fly, it actually says on here where it is now, but I believe it's in PIDs. Yeah, PIDs mechanics, that's what I thought it was. I re-recorded this part because I wasn't sure. But yeah, if we go into PIDs and mechanics, and right down the bottom we have this level trim degree. So if we put the 5 degrees in there and save it, that's all done. It's no longer you have to worry about negative or positive. Positive is always a nose up angle, negative is always a nose down angle. And it bases the front based on the board alignment that's set in the CLI. So, or if you're just changing yaw, for example, you can just set it in configuration. So if we say yaw 180 degrees, the arrow is pointing towards me, but that pitch alignment knows that this is the front. So +5 is always going to pitch the nose up. So that's made things a lot simpler. The auto level part is actually, it will calculate that angle for you in flight. So you have an auto level mode on the modes tab, surprisingly enough, and you can use that on a switch to switch it on or off. It will only work in a self-leveling mode, so that's angle or horizon. And what you need to do is just let go of the sticks for a few seconds, and you can watch the vario, and eventually it will just level out to 0. And once it gets to 0, it's set your new pitch. So that's what the auto level does. And the other pull request is just the variable in CLI that it added. But yeah, don't get auto level confused with self leveling, which unfortunately seems to be happening. Right, the next thing is a bit more advanced. So if you're a new pilot to iNav, or if you're not an experienced PID tuner, I would just ignore this one for now. Future versions, there will probably be defaults set up for this already. What people like Alex and Mark are investigating are ratios between P and D to get a nice balance. But yeah, if you're new, I would just ignore this one for the minute. But what this is doing is adding a derivative to the old PIFF controller. So iNav for fixed wing now has a PIDFF controller. And what the D term does is it's a predictive term. There is a whole tuning series that I did with Mark where he explains everything very well. So I'll leave a link to that up in the corner if you want to understand the PID. Well, at the time it was PIFF, but we did cover D, I believe, a little bit in there as well. But basically, when you're flying iNav, there is a set point, and you have the proportional control and the integral control. That's how the old system worked. And the set point is basically the degrees per second that you want the plane to rotate in on a specific axis. So what you'll do is the feed forward just follows the set point. And what that does is create an area for the P and the I to work in. So the set point will move, the feed forward will be exactly where the set point is. And then what the P will do is grow to try and push towards that value. So say, for example, we want to rotate at 100 degrees per second. The set point and feed forward will go straight to that 100 degrees per second, and the P will push further out to try and get the actual rate to that target. If it finds it's not updating quick enough,
the I term will gradually wind up and push it harder to get to that target. And the problem that you have here is there's potential for overshoots. And what the D does is it predicts how long or how quickly you'll get to that target. And what it can do is actually lessen off the effect as you get closer to it. So it, instead of bouncing past and then coming back, it will actually sort of try and stop dead on that target. And of course, this is all happening in fractions of seconds. So yeah, you'll just notice it just getting to that point and stopping. So that's what the D is potentially going to do. It's going to create a much more locked in plane. So as soon as you let go of a stick, or as soon as you get to an angle, it will get there, do its job, and then go to the next command point. But again, this at the moment is still quite experimental. So unless you're confident with your PID tuning capabilities, I'd leave it be for the minute. But it is going to be a very, very good feature. So the other thing we have now is continuous automatic servo trim. Now this is a feature in iNav, which means you enable it on the configuration page. And when you enable it, it will also get rid of the old auto trim mode from the mode screen, because there's no sense in having them both, to be honest. They're basically going to do the same job. The continuous will basically work when your sticks are centered. It works in stabilized modes, so angle, horizon and acro. But what it will do is measure the difference, and again using the I term, just to see how much it's pushing to maintain that level. So once it has these inconsistencies, what it will do is then translate this to your servo midpoint, which it does relatively slowly over a period of time. But of course, where it's adjusting the servo midpoint, it means that if you turn out of a stabilized mode into manual, that trim still applies. It just doesn't adjust in manual. If you're using auto trim on a mode, it's basically the same. It will still save the trims once you disarm, so that the next flight they will be there. But yeah, it's not an excuse for having a badly set up plane in the first place. So if you used to manually trim and then physically adjust your servo linkages to get it all right, still do that. But you can still enable continuous auto trim, and that way it should trim out any differences in like day-to-day wind conditions, that sort of thing. So it is still very helpful. But also if you were one of these people that didn't manually trim but used auto trim and then checked the servo midpoint, it still ideally wants to be within that 1450 to 1550 range. The closer to 1500, the better. So if you did the auto trim, found that it was too high, mechanically adjusted and then centered back to 1500, you still need to do all that with continuous auto trim. But it's one less thing you have to worry about switching on. Basically, it's just there working in the background. And the idea is that day-to-day differences are catered for. Also, potentially speed differences. There's also a safety margin. It will only ever go to, I believe it's 1700 at the top end and 1300 at the bottom end. So it won't ever trim the midpoint all the way over, so you've got no control. You'll still have 30% of control over the range of the servo. So that's continuous auto trim. Now, you may have seen videos, I think Adam G had this issue. Actually, yeah, Adam G had this issue where he basically has auto launch set up with an idle throttle. He threw the plane, but it wasn't enough to trigger the launch had happened. But the idle throttle was enough to actually keep the plane airborne. So the plane was just idling basically around the sky. This feature is actually now using GPS speed to detect what's happening in the launch as well. So if you throw it and this happens, it will detect, hang on, I'm still moving, we're actually launching, even though it's not trigger the launch. And then obviously it will trigger the launch. So it's quite useful for getting around that issue. Next thing is quite useful for, I believe, people that still use older transmitters, like PPM transmitters. There's now a pre-arm mode. So you can have a switch to pre-arm, then an arm. Now, I believe pre-arm is usually on a momentary switch, so you'd hold it into pre-arm, set it to arm, and then let go of pre-arm. So if you disarm, you still need to pre-arm again.
it has actually been updated so you can use it with a regular toggle switch and it will time out. So that's quite a useful feature. I mean, I never really got it, to be honest, but I've heard from people who are using stuff like OpenLRS, where they don't have things like failsafe bits, so they have to send the failsafe over the with actual channel positions. And the problem is, if they accidentally lose signal on the ground, that can trigger the failsafe and the plane will just start flying. Well, or the motors will start up anyway, which obviously is not a good thing. If it's failsafing, it's already armed, it's already flying, so the switch position for failsafe will just keep the arm active if you do failsafe. Whereas if you're on the ground, you've disarmed, but then you switch off your transmitter by mistake before unplugging the battery, it won't, that failsafe condition will then say, hang on, you haven't pre-armed, I'm not starting the motors. So it's useful for that. I believe it'll also be useful for FlySky because they have to use the channel positions as well for their failsafe. So it's, yeah, a nice useful feature, which I didn't really consider only using receivers with failsafe bits, but yeah, that's why it's in that list. Right, so there is a new option for return to home. If you have climb first set, you can now choose between a regular straight out climb, which is the current and default setting, or you can change the option to be a spiral climb. And what that will do is start loitering the plane, but gain elevation in a loiter. So why is this useful? Well, it depends on your flying environment. So if, for example, you're in a reasonably tight space, or something like a mountain range where something could come out in front of you, then it's going to be useful because it will basically get you to your return to home altitude within your loiter radius. So you don't have to worry too much about hitting things. If you're flying somewhere like me, where I'm between two rows of trees that are closer than my loiter radius, so I'm still going to keep mine just climb straight out because there's more chance that I'm flying towards an open space. And if I turn first, there's more of a chance that I'm going to hit a tree. So again, this is very environment specific. But if you're flying somewhere where there's no obstacles at all, you can use this just to get the height without actually going any further distance away before coming back. Or of course, the option is still there just to turn first and then climb on the way back. That is still ultimately going to be the most efficient because you're climbing on the return journey. Spiral climb is like a halfway house, if you like, so it's going to use more power than the return first, but potentially less than the climbing away. Of course, if you're flying towards the home point when you do return to home, it's going to be the same as turn first anyway, effectively. The other thing is, if you, for example, again, are in like a hilly or mountainous area and your return to home mode is set to max, you could find that if you just use the standard climb out before returning back, that you may run out of distance before your RTH will say, hang on, I've flown too far away, I'm just going to fail safe and land it. So this is the setting right here. So there's the RTH sanity check. So if you fly away further than 500 meters, it will think that the RTH is going bad, so we'll enter an emergency landing mode. If you're using the max return to home, or at I think there's one where you can have max and at least, so there's a distance above the max, you may find that if you're just returning to home, climbing in the direction you're facing, if you're quite low and that altitude for return to home is quite high, you may find that the 500 meters distance gets used up before you actually reach your altitude. So that's another reason why the spiral climb will actually be beneficial in that scenario. So again, it's an option for people to use, and it's dependent on your flying environment, but yeah, nice, great option that's been added. So if you fly a plane with a rudder, there are a couple of improvements. There are improvements on the turn assist, and also there's a freeze on the I-term for the yaw. And the reason for this is the rudder was sort of overreacting a lot of the time.
And a lot of people just turn the rudder stabilization off completely and used just the RC input for rudder. So these new adjustments, you should be able to tune the rudder so you can still have stabilization, but it won't overreact the way it used to and will actually be nice and flyable. So yeah, have a play with those settings. If you have a rudder, you'll probably end up with a better flying plane. Right, there's a mode name change with regards to cruise. So what you originally knew as cruise, which was just basically a heading hold, is now called course hold. And that will do exactly the same as the old cruise mode used to do, and just fly sort of aiming at a specific target. What used to be called 3D cruise is now just called cruise. So that has the altitude lock and that course hold. You don't need to use altitude hold mode with either of these anymore. You can just use course hold for course hold and cruise for the old 3D cruise. If you use course hold with altitude hold, it will just do the same as cruise, but it just makes things a lot easier, not even having to worry about altitude hold and just having the two separate modes. So yeah, I'm just going to be setting up with course hold and cruise from the future. But yeah, it's basically just a name change to make those modes more realistic compared to full-size aircraft. That's why a name change took place. Right, return to home overrides. Now this is quite a cool feature. So I mentioned the spiral climb earlier, but if you don't really know the environment you're flying in, you might just set an average return to home that works well for you most of the time. What the overrides will allow you to do is change the way it functions. So for example, if by default you have climb first set as your return to home, if you hold the roll stick all the way to the right for 1 second, it will turn first. So it will forget the climb, turn first, and then start climbing. So depending on your environment, that might be beneficial to you. You can see in your goggles what's around you. If you decide, actually, I can just turn now and then gain the altitude on the way back, just use that override. There's another override where if you decide, well, actually, I'm high enough already, I don't need to gain any more altitude. If you push the stick up, so not pitching the aircraft up, but push the stick up for 1 second, it will just lock at the current altitude. So for example, your return to home altitude is 100 meters. If at 50 meters you decide I'm absolutely fine, hold the stick up for 1 second and it will return home at 50 meters. If all of a sudden you decide, actually, no, I need the 100 meters, there's a tree coming up or whatever, you can hold the stick down for 1 second again, and it will then resume using your original return to home altitude. So that's a really nice feature that's been added. All right, there's a couple of things that have changed on the OSD. There's a new glide slope element. This is really, really new. It was literally added, I think, a couple of days before the release came out. So I've not really even had a chance to investigate it fully, but it will give you, I guess, the angle that you're actually gliding down at. I've had a quick look at it on the OSD, but as I say, it's a new feature. I've not really even had a chance to look at it yet. Yeah, it was merged, I think, 3 days ago. 4 days ago now. So yeah, 3 days ago when 3.0 came out. But I thought it was a cool feature and people would ultimately like to know about it. Right, Sentinel tracker support. Now, this tracker is something that I only heard about myself a couple of days ago in a chat group that I'm in. And it actually sounds really cool. What it actually uses is a hidden line on your OSD that is sent back through your video. So it actually uses line 0 of your OSD. This only works on the Max 7456 OSD chip, so it won't work with Pixel OSD. Maybe that's something that will change in the future. But the really cool thing is it will work with iNav now. It should be able to work with Betaflight. I think you have to have a separate target. It works with RGplane. Where it's on the OSD, it will work with pretty much most flight controllers, so long as they support this line 0 sending whatever data it sends to the tracker. Yeah, there's no additional things to set up. Of course, it relies on you having a decent video signal, but there's always a price to pay with whatever method you're using for these trackers. There's a link to the tracker if you're interested in having a look. There are a few arming screen changes. The one that people will really appreciate is now it will say whether a waypoint mission is loaded or not. So I've put the pull request to that, but also just off the top of my head, you can actually now choose whether you show your GPS coordinates on the arming screen or not. And I think there's a couple of other little changes that I've not listed. You can select the speed source now for your DJI OSD if you use the DJI system. So you can select between ground speed, 3D speed, or air speed. Again, something I've not really investigated in a great detail, but something that is really, really cool if you use a pan tilt system. Previous change, if you had a pan servo, no matter what direction the camera was facing, the home arrow would always stay the same direction. What you can do with this is actually set up, again, I'm not sure of the detail, but you set up how far your camera can pan either direction. And then when your camera turns, the home arrow, so say camera's pointing straight ahead, home arrow's pointing straight ahead. As my camera turns, the home arrow will actually turn to show the direction of home based on the view of the camera, which is absolutely awesome. So you never sort of lose track of your home position, or you don't have to then center the camera just to see where your home position is. You'll always have an accurate home position based on the using this feature. So yeah, if you use a pan and tilt, I'd recommend definitely checking that out. And then I've got a few basic changes that we won't go into in too much detail because this video is quite long already. The OSD switch and LED low have been renamed just to make them easier for people to use, so just more obvious names now. DShot beeper has been implemented, so the motor will actually call out beeps for, I believe it's RX signal and stuff like that. The maximum loiter radius has been increased to 300 meters, just in case your model is absolutely massive and you need a big loiter radius. Something that Josh will probably like is that 12S is now supported. Yeah, it's up to 12S now for cell counts and voltage calculations, that sort of thing. There's an improvement in the way that GPS failure is handled. So now on the OSD, you'll have an X with an exclamation point where the GPS satellite number is if you lose GPS signal, because basically if you lose signal, all the GPS data that you have is basically worthless. So this will actually let you know that you have a failure. There's also a GPS valid fix added in the iNav programming system, so it's now really simple to check whether you have a valid GPS lock or not, and this also covers the hardware failure too. So you can put sanity checks in any of your iNav programming code. We have now support for MAVLink and MAVLink v2. The failsafe procedure can now be updated in the OSD menu, so if you want a different failsafe in the environment. I mean, for fixed wing, maybe this is less relevant, but you know, it could be that you're flying in an area where you would rather it just land than try to carry on with a flight or return home. But you can change that quickly now in the OSD. Cell voltage is now included in Crossfire telemetry. There is some ghost telemetry support added for GPS data. Delayed safe homes is quite useful. With the original Safehome system, if there was a safe home within the distance, it would then change your home point to that safe home location. Functionality has now been added so that you can choose how it works. So there's RTH, which is any RTH at all will use the safe home. There's RTH_FS, so it'll only use the safe home on failsafe, or there's off, where it won't use the safe home at all. And the OSD message has also been changed. So if you're returning to home, it will still say returning to home. If you're returning to a safe home, it will say diverting to safe home. So you can actually see what's going on your OSD system messages. There are more mode ranges if you need them. Default loiter radius has been increased to 75 meters. Again, this is trying to cater for slightly larger aircraft. So you may want to reduce that if you've got a small flying wing, for example. But this is so that bigger aircraft have got a much better chance. The loiter radius will be good for them. There's a shorter plus code that's been added. So it removes the first 4 digits from the plus code, so you have a much less intrusive plus code in your OSD. What this means is if you need to use the plus code, what you have to do is find a plus code reasonably local to where the aircraft is, take their 4 digits and put them on the front of the plus code in the OSD, and then that will find where the aircraft is. Of course, if you're using telemetry, you can still send the full GPS coordinates back to your transmitter, but this is just for the OSD. But yeah, it will make things look a lot neater. Throttle smoothing has now been added by default, so in navigation modes the throttle changes should be a lot smoother, which will hopefully lead to less issues with potentially dolphining. So if you found that it would increase throttle too much then lower it too much, you end up having this sort of thing going on just based on trying to keep the altitude with the throttle. Well, where it's smoother, it should just get an average and should keep it much more level. Okay, so you can now add the version number to the OSD, which is good for tuning. For example, if you have a tuning OSD, in fact the iNav Fixed Wing Group Pro model tuning OSD is now having the version number in the top left hand corner. Well, what it means is if you're asking for help, the version number is already there so people can see what you're using. But also for records, if you're keeping video logs of your tunes with iNav, you can then just have the iNav version on screen. You don't have to worry about forgetting it, it's already there. Right, Safehome safe distance has been increased from 200 meters to 650 meters. So if your field that you could safely land in is a little bit further away, you can still now use Safehomes with it. People did want this increased quite a lot, but the problem is Safehomes was never intended to be an alternate landing site kilometers away. It was only ever supposed to be, I'm flying in this field here, there's a field next to me that has a lot more space, so I can put the Safehome right in the middle of it, and if I need to do an emergency landing, I won't hit anything. It was never intended to be, I'm going to fly from here to here 2 kilometers away and you land at a Safehome. The whole point is you can still see where you're landing, or you could still get to where you're landing pretty quickly if you needed to. F3 targets are gone, won't even go any deeper into that. If you're worried about future-proofing, F411s are likely to be the next to go. After that, F722s. F405s are still going to be fine for a long time. Same with F765s, if you can get them at the moment. Right, SBUS servos and PWM servos can be used simultaneously in 3.0, which is great. I know Hamish is going to be really happy about that, because he's using an SBUS output to control his infinity pan on his clouds. So there are a few new targets and new target variations I've just listed. If you want to look at those, you can. And now we're getting into the configurator changes. In Configurator, you need to use 3.0 Configurator, which I showed you how to download at the start of the video, for iNav 3.0. You can put 2.6 on it, but all you'll get when you connect is the CLI. Everything else you won't be able to use. So let's take a look at some of the changes in Configurator. Now, the first thing, I'm not looking at the list, but I can see the first change already, and that is this flying wing, which is awesome. Now, this appears when you select flying wing from the mixer. You know, technically, this might not be a flying wing. It might be a plane with elevons, but it's called flying wing. But you get that. Unfortunately, in 3.0, if you choose any of these other airplanes, we're still stuck with a clean flight box, but there's something coming soon in iNav 3.1. Anyway, let's have a look at our list. Right, fixed wing presets. Now this is going to be fun. There's presets. All the individual model presets are gone. You don't need them anymore. You don't need to ask people for PIDs anymore. Completely forget about all that crap. It's gone. They don't exist anymore. Asking what's your PIDs, irrelevant. PIDs are relevant only to your model. If you use different servos, if your plane is heavier or lighter, if you have different physical throws on your model, all these can change the PIDs and the rates. So having rates and PIDs even from identical planes with what you think are identical could be wrong. So what you now have is a very, very simple choice. Does your plane have a tail or does it not have a tail? With regards to this, forget about elevons, forget about all this. This is the physicality of the plane. This here is an aeroplane without a tail. This is not a flying wing. It has elevons, but it has no tail. If it had something extending out the back with an elevator on it, like the Sky Hunter wing over there, that would have a tail. Don't worry about rudders. It's just, does it extend back and have a elevator effectively on there, or a stabilizer? If it does, you're choosing aeroplane with a tail. So that's going to include things like mini Drax or Drax with a boom kit, for example, Sky Hunters, Albabirds. I think I listed all these at the start of the video. But yeah, anything like that with a tail, choose with a tail. If it's like our Dart here, which doesn't have a tail, you choose airplane without a tail. That's the only choice you really need to make. That will apply some basic PIFF settings and also set the moderate rates that we were talking about earlier. So you basically set those and then go do your auto tune. There's not really a lot more to cover in that. It's something that you just need to do and then go and tune and fly your plane. Right, so programming. There is RC channel override that now works in iNav 3.0, and also you can see we now have PID controllers. If you're interested, have a read and have a play. I'm not going to dive too deep in this video because, to be honest, I've not dived deep myself yet. Other changes, right? Mission planner, or mission control, I should say, has had a few options added. Again, I've not investigated this. I've just put this up as a change of note. So if you're interested in missions, I've never actually used a mission. But anyway, I'm not going to play with that. If you're interested in missions, there are a lot more options available to you. So go check out that pull request and have a read. Advanced tuning page. Right, now this has changed quite a lot. So it does take a little bit longer to load now, but it provides only information that's relevant to your craft. So we're flying a fixed wing, so we have fixed wing settings, and then we have generic settings that apply to everything. If you're flying a multi-rotor, you'll have multi-rotor settings up here. If you're using a rover, you get everything at the moment because there isn't really anything specific. I did sort of speak with Pavel about this, but yeah, you're just getting everything at the moment. But fixed wings and multi-rotors have nice neat pages now where you can just have the settings that are relevant to you. Yeah, flying wing model, we've already covered that. Right, remove home position from arming screen. I believe I mentioned this briefly while we're talking about the OSD in the firmware updates. But yeah, you can now hide the home position from the arming screen. Battery voltages have been neatened up, so we have voltage and current sensors in one section here, and we have the battery section here, which is just easier to get at, nicer to get at. Thank you, Alex. Right, maps are now full height. So if we go into here, we can see the map is the full height for screen. If we go into GPS, I thought that was going to be the full height for screen. No, it should have been. Emission controller, so even slightly too big. Okay, so that may be something that could be changed slightly, but before it was a smaller map. And the modes have been rearranged. Right, let me just lie and say I have a GPS on here. So I'm just going to fake a GPS so we get all our modes up. And if we now pop into modes, you can see no longer do we have just sort of random orders. We actually have, even though you can't see them, they're in sections. So we have arm and pre-arm. Then we have flight modes, so angle, horizon, manual, return to home, position hold, cruise, cruise hold, modifiers, so we have heading hold, we have waypoint missions, home reset, so this is all related to navigation. We have our servo auto trim, auto level, auto tune, so it's all tuning in one place. We have launch mode, loiter change. All the OSD stuff is now together. All the camera stuff is together, and then we have some various stuff at the end. So you can see it's going to be much easier for setting up your flight modes. They're all sort of in nicely grouped locations. And something that hasn't been added, but the pull request is in for, is the option to hide the modes that you're not using. So once you're set up, you can click the hide button and you only see what you're using, which would be really nice for confirming stuff. But let's have a look. Yeah, that's the end of the document. I hope you guys found this video useful. If you did, please give it a thumbs up. Don't forget to let me know in the comments what you're most looking forward to using in iNav 3.0, and also don't forget to subscribe. But all these things will help get this video out to more people so they can learn about the new features for fixed wing in iNav 3.0 too. Thank you guys for watching. I'll see you on the next one. Fly your models like you stole them, because it's lovely and sunny outside. See ya.